Next up, we have Shubham. He's working as a PhD student at CISPA at the Secure Web Applications Group, abbreviated as SWAG. And I love this acronym because I hope you get cool swag at SWAG. His Dr. Vater, I'm not sure what's the name in English, is Ben Stock, who also graced the stage of past German OWASP days. So you give a round of applause to Shubham, and he's telling us a bit more about how fingerprinting can go bad.
Okay, yeah, mic check works. Okay, thanks for the kind introduction. Yes, my name is Shubham, and I'm going to talk about browser extensions fingerprinting. So the lightning has calmed down, and because it's a research project that was accepted this year and was published at CCS, so let's see how browser extension fingerprinting. We heard about network fingerprinting earlier this afternoon, but that was for users' protection. But again, fingerprinting is a very broad term, and it could go wrong for users as well in some terms. So I'm going to the most interesting slide next. Oh, that's about me. Yeah, so as mentioned, yes, I'm doing my PhD at CISPA Hemot Center at Saarbrücken, working with Ben Stock. But yes, I like to do application security. For most part of my PhD, I look at browser extensions and also web privacy nowadays. Okay, yeah. Before I talk about extensions fingerprinting, how many of you use browser extensions on a daily basis, if I may ask? Okay. Expected. Less popular question. How many extensions have you developed, or have you developed any extension at all? Anyone? Oh, okay. Those are numbers that I did not expect. That's a good number. Thank you. So for those of you who haven't, let's look at what browser extensions normally are. Yes, third-party client-side add-ons because you use them, and they enable a lot of features, like, for example, password managers, ad blockers, and whatnot, right? They have different components. For example, manifest or even content script. Why there are different components? Because they have different level of capabilities. Content script face the website that the users visit, so they have lower privileges. But then there are other components like the background, the core of the extension, which has higher privileges. And those are the things that make extensions interesting. Well, yes, browsers are popular among users, but because they're also available on most widely used browsing platforms. And they are just not available, they are like really, really popular. I'm putting out Malwarebytes and MetaMask because we will come back to that, but there are many more popular extensions. Okay, this was it about extensions. Now, coming to the main crux of it, fingerprinting. Why do we care about this, right? Well, with all the fuss going around third-party cookies and its deprecation, how people could track through cookies, right? I mean, cookie-less tracking is gaining traction nowadays, right? And interestingly, there are fingerprinting libraries, like Fingerprint.js and even Castle. They claim to have already incorporated extension-based fingerprinting in the suite. But in my opinion, I believe that these are the ones that they speak out loud, but then there might be many more libraries which actually do that. Well, yes, extensions, they do various kinds of functionality on the client side, right? And of course, these could be unique based on individual extensions. And these individual behavior could lead them to be actually getting fingerprinted. How do we know about all this? Because there are a handful of research works done in this direction. Yes, the first one that I could remember was even 2017, but there has been many follow-up research on that. But is that it? Is that all? Why do we care? Yeah, okay, fine, users are being tracked anyways, right? What makes it interesting? Are we only talking about users? Yes, we know for a fact that users may be tracked with or without extensions, but could it go beyond that? That's a question here. No. Well, I guess you might be familiar with this page, right? Ad blockers being detected. I mean, if you're an ad blocking extension, this might be not so familiar face for you guys. But yes, how are ad blockers detected by websites? They are fingerprinted by websites. And then I recently came across this Twitter post where apparently LinkedIn is trying to understand which sort of extensions have their users installed when they browse onto their website. This might be a new thing. This might be even an age-old thing. I don't know, but came to my attention recently. So bottom line being that websites are also pretty much interested, even when they are not tracking, that what sort of extensions you may have installed as a user when you visit to their website. So, okay. Should developers be even aware or concerned about this? If we look at ad blockers example, probably yes, because then their functionalities are affected that way, right? So what do we do about this? We took a step back and thought like, okay, there are many approaches, many research works done in this direction. Could we contribute in some sense, maybe which is not discovered in empirical sense? And we took a step back and tried to convince ourselves by the trend that we observed that yes, extensions do a lot of JavaScript stuff or often inject JavaScript into the page that one visits. So for example, if I visit foo.com with Malwarebytes installed, Malwarebytes might inject a script directly into the web page foo.com. So what could happen with that? So yes, we have an extension on a website here, and the website will have its own JavaScript and the main content. And here goes the extension script that gets injected. And it's interesting to observe the sequence or the ordering of the script that is shown here. Yes, so in this very example, we see that this injected script tries to write into the document title, but the web page JavaScript has already overwritten the native definition of document.title in some sense. Could this go wrong? Well, actually, yes, because this then allows the web page JavaScript to capture all following invocations of this API. Because the JavaScript here, in the injected.js, actually executes in the same context as well as same JavaScript namespace of the web page. And web page JavaScript, by simply overwriting all the available APIs, can observe the execution traces of everything that happens inside injected.js. And that's problem number one, by the way. What else could happen? Let's see another example. And that was document.title, which is like a property, right? And now we are talking about another example in a similar sense, which is like an API now. We are talking about for each operation, which is like very popular JavaScript operation, right? Again, in a very similar terms, the web page JavaScript could go beyond overwriting the properties, but also write the APIs now, and then capture all following invocations that the extension injected script could execute at runtime. And then try to uncover fingerprinting traces based on individual extensions. Yes. So that's problem number two. What could you do when when you overwrote an API? What does it allow you to see? Like, how do you capture invocation fingerprints? So the overwritten definition could allow you to capture the caller code and the parameters. So for example, in this case, we see foo bar and bars passed as the entries, which are the parameters. Of course, you can capture that, right? But more importantly, you can also capture the stack trace of the executed API. Because in some cases, for example, if the script uses strict primitive, the caller code is not visible. But stack trace still is, and that gives a very fair amount of entropy to uncover fingerprint traces, because it gives you the line number and all the script traces there. Well, is that it? Unfortunately not. Think of more simpler terms that we came across. The injected script now sets a global variable in the namespace of the application. Again, the website script could just iterate over the window object and try to infer like what sort of variables were set by the website itself versus what could have been set by an extension that they knew. And they could just simply extract all the global variables here to, again, extract the fingerprinting traces. That's problem number two. So the bottom line here being, if a script is injected by extension in the namespace of the application, there are execution traces which are definitely visible by the application. And then there exists another case, Well, extensions, they might need to store data on the client side. Of course, they have dedicated APIs for that, but they may still go ahead and use the web storage APIs or the APIs that are basically available to the websites as well. How that may look like? Well, I mean, if we are talking about, for example, local storage or even cookies, because traditionally cookies were used to store data, or even IndexedDB, the problem here is that these APIs are still accessible also by the website JavaScript, and any data that is stored by extensions, well, is also accessible to the website, and then this could lead to fingerprinting. The post message API, similarly, if an extension uses post message API in their content script, because it's a web-facing script, the website could just simply register an event listener there, and then could listen to all the messages. And no origin level check could work, because content script, since it executes in the same origin, no origin level check would work there. And that's the problem with the post message API. So these are the problems. What do we do about these problems? Do we try to understand on scale? Yes, that's what my focus was, to understand this on the large scale, like how many extensions are actually affected by these kind of behaviors. So yes, to build a large-scale pipeline, we give fancy names, and I gave it Raider. How do we go about this? So we asked this very generic question: how many extensions actually are affected by these kind of vulnerability or fingerprinting issues? So we basically looked into we basically downloaded all the extensions from the Chrome web store. Looking into it will take some time. Downloaded them and then built this all automated pipeline by looking into their manifest. Manifest, I don't know if you are familiar with the Android ecosystem. You have the same manifest there, which is basically the blueprint. You see all the permissions and everything there, which also applies to extensions. We try to understand how many extensions actually even operate on any arbitrary web page that the user might visit. Based on that, we select those extensions for next test. And that next case is like how many extensions can even inject scripts in any of the arbitrary website. And if they do not include any script in the manifest directly, but has permission to do so, which is like another level of just executing script arbitrarily, we include in our data set, which gives us roughly around 38K extensions that we analyze later on. We load each of these extensions individually on the browser and visit our specifically crafted honey pages. What this honey page is basically, it has like a list of all the HTML elements which the extension might be interested in to induce some sort of functionality so that the extension is triggered and shows some behavior. Well, yes. So visiting this honey page gives us some traces that we collect to our server, and then at the end of the data collection phase, we basically analyze this to understand, are these traces unique enough to be called as a fingerprint, and then are these fingerprint actually uniquely identifying for individual extensions. So yes, this is about the pipeline, but then next, what did we do with our pipeline? We have some numbers now. Yes. So out of all the 38K extensions that we analyzed, we found 2.7K of them to be fingerprintable. Mind you, this is an extreme lower bound of the numbers, because A, we do not log in or we do not select extensions that only work on certain domains. We do not do fancy monkey testing or anything like clicking on stuff. So this is an extreme lower bound, but still 2.7K extensions were fingerprintable. And if we go down, breaking into the things that we discussed, the problems, we see that the script injection behavior of extensions are actually really interesting for fingerprinters or trackers, because that gives us the majority of the numbers among the 2.7K. Around 1,200 or so were also fingerprintable through global variables. Of course, this is like very minute thing. One could always think of, why somebody would use var x equal to foo or something, but that happens apparently. And then there were like around fraction of extensions which were also fingerprinted through storage. Well, there is a dedicated API, but still happens. Okay. Combining features also works. So an extension might just not be fingerprintable through one vector, but then combining features work, and that also shows in our numbers. But talking about more realistic terms, if you have multiple extensions installed as a user, this might create conflicting behaviors. Well, We try to reach as realistic case as possible. We tested across multiple extension sets. We tested with a sample size of from 2 to 10, and then actually we came to this conclusion that the fingerprinting strategy that we found actually works in 98% of the cases. So it's not really affected by how many extensions have you installed. Are they conflicting? Are these fingerprinting traces lost? If you try to get as realistic as possible. Okay, quickly. Yes, I talked about Chrome extensions, but does this translate to other platforms? Because the underlying API remains the same. Well, actually, yes. Of course, the number of extensions on the Firefox store is much less. But if you look at the trend here, it's pretty much similar in terms of like which vectors contribute most fingerprinting traces. And yeah. Well, what do we do about numbers? We talk to developers about this. Like, what do they think about this as a problem versus if they can do something to fix this? For all the people that we could get their email ID and such, we informed them about the problem, and then we also provided them with a test bed to, if you as an extension developer are building something, or if you plan to build something tomorrow, you can always test your extension through a test page and see that whether or not you're fingerprinted. We did not receive a lot of responses, but then from those that we received, of course, some of them positively acknowledged the problem that, yeah, okay, looks interesting, never thought about it. Maybe we can do something about this in the coming term when we push some updates and whatnot. And then there were some comments about, okay, yeah, this one, that, this is not a responsibility. It should be browser's responsibility, actually, to fix these. I mean, we are just developing extensions. But unfortunately, at the browser level, there is no solution at all, because this is an architectural problem. Scripts are supposed to be injected on the web page because that's how extensions work. Well, this is what developers had to say. And, majority of them did acknowledge the problem, and they showed some signs of responsibility there. Okay, so we have a problem. Can we do something about this? Not concretely because it's an architectural problem, but we can still provide some set of guidelines for existing extension developers or new ones. I don't know. If we go about looking at the problem, the crux is that the injected.js in this case, executes after web page. Can we do something about it? Can we flip this order? Actually, we can with the new extension standards. There is a way to do this. If you execute your content script into the main world, this is something new term, relatively new term. By its design, content script is always isolated, but then if you specify it to execute in the main world, it is the first script to execute, and also the web page cannot do anything about it. So that's one of the recommendation that we put for developers to think about if it could work in some cases. About global variables, of course, one could use JavaScript primitives like immediately invoke function expressions to avoid any context that remains. And similarly, local storage or web storage, it's pretty simple. Use the Chrome.storage API. It's as simple as that, so that websites cannot access to what you stored. Okay. Then that brings me to the end of my presentation. To summarize this, yes, we discovered some new cool vectors to fingerprint browser extensions, and we found around 3K extensions across web stores to be actually affected by a methodology. Unfortunately, the modern browser architectures do not have a solution. And I don't know if I can talk about this with the time. I did manage to get hold of people from Chrome and Mozilla last month, and tried to discuss this at length about this, if they know about this or even have a plan to solve this. The thing that I can share is that they did acknowledge the problem, but they said like, yeah, okay, maybe we need to think about this. It's a problem, but we don't have an immediate plan, which is most often the case. Well, yeah, that's pretty much the sign that I received from last month. Well, yes, we did notify the developers about this, and then they said, yeah, it's not a malicious behavior. It's an intended, it's a benign behavior. We need this. That's how extensions operate. Well, and then, like for research or for anyone interested in browser extensions fingerprinting, we open source our data set and our test pages. please feel free to have a look into our paper or on the test page for more details. And with that, thank you so much for listening to me. And yeah, please feel free to ask me questions now.
Right, as mentioned, this is not a lightning talk, so we have indeed time for questions, and the first question is from Freddy.
Did you try pitch those test pages and honey pages specifically to the browser vendors and say, hey, would it make sense to incorporate this into your testing? I assume that there is some sort of automated testing going on when you submit an extension. And then the next question is, I think, which is kind of the underlying question, whether they want to include this in the automated testing. Is fingerprinting sort of in scope in terms of something that extensions should develop? Are there actually policies, or is it basically YOLO at this point?
Okay. To answer your first question, thank you for the question, by the way. It's very interesting. For the first part, we did not actually think about pitching this to browser vendors in the beginning. I think it was an afterthought because we talked to developers and we received some feedbacks, and we thought, yeah, okay, fine, we should talk to browser vendors as well. I don't know what it was, 6 months back. I don't exactly remember what happened, but it was pushed to a later stage as a follow-up study, is all I can say for now, to talk to browser vendors at length about just not fingerprinting, but a few other things as well. We did not plan to pitch the test page because this is just about one or few specific fingerprinting vectors, and as I said, there are many more fingerprinting vectors. We are not the first one to invent extension fingerprinting, by the way. So that was the idea behind not just particularly pitching the test page to the browser vendors, but to bring the awareness about these kind of issues. I don't remember the second question. Sorry.
So there are extension guidelines that people need to adhere to if they submit, and I was wondering if fingerprinting is mentioned at all in these kind of submission guidelines.
I have not come across a particularly, a particular guideline in any of the web stores or anything that talks about extensions fingerprinting. But with Firefox being so privacy supportive about how extensions were previously fingerprinted through the URLs, and then enforce randomized URLs, like after the 2017 study that I mentioned. So, and then Chrome also went into this direction. They included this property in their manifest called use dynamic URI, and they started enforcing this last month or last week, I'm not 100% sure. So it's still the other way around. Developers could choose it, but so it's coming into the traction of browser vendors is all I could say. It's not a guideline per se, but it's more like a S&P practice that developers should be aware of, or even vendors could do something about to ensure privacy of users, in my opinion.
Okay, we could have maybe 30 seconds for a very quick question. Are you still using any fingerprintable browser extensions because you couldn't get rid of it?
As I said, Malwarebytes, I'm guilty of using Malwarebytes still, but for research purposes. That's all I can say.
Okay, perfect. Then give a round of applause to Shubham.